Hello, this is Jonathan with ROBOTIS, and today I'll be discussing various methods for synchronizing the operation of your DYNAMIXEL actuators. One of the key features of DYNAMIXELs is the ability to chain multiple actuators together for seamless integration and coordination of multiple units, making them ideal for applications such as humanoid robots and robotic arms. With daisy chaining, actuators can be connected in a series, reducing the need for excessive wiring and simplifying overall system design. This not only saves space, but greatly improves the efficiency and performance of the entire system. Additionally, the addressable IDs enable precise control and performance customization through allowing the adjustment of position, speed, and torque of a single actuator or synchronized groups of actuators. This flexibility opens up a world of possibilities for robotics enthusiasts and professionals, allowing them to create dynamic, responsive, and intricately coordinated robotic systems. However, this feature also raises an important question: how can I synchronize my DYNAMIXELs? In this video, I'll discuss several methods for achieving synchronized operation, explain how best to utilize them, and hopefully allow you to determine which method is best suited for your use. The first method of DYNAMIXEL synchronization is the Shadow ID feature. This allows you to assign a secondary, or shadow ID, to your DYNAMIXEL actuator in addition to their primary assigned ID. Normally, DYNAMIXELs can't share IDs with any other actuator on the same network. However, shadow ID numbers can be shared across multiple DYNAMIXELs. This allows you to control multiple DYNAMIXELs at the same time by sending a single control packet. For many applications, this is the simplest way to coordinate synchronized DYNAMIXEL movement, as it doesn't require any additional hardware components or software configuration. You can simply address the DYNAMIXELs with the shared shadow IDs as if they were a single DYNAMIXEL actuator. However, there are a few important considerations when working with shadow ID numbers. When possible, the secondary ID assigned to a servo should be different from its primary number. Sharing a secondary and primary ID on a single servo will introduce delays in command execution and may cause movement desynchronization. While commands sent to a shadow ID can modify RAM area control table items, they can't modify EEPROM or protected registers such as position, voltage, or temperature limits. Status packets will not be returned for any commands sent to an actuator's secondary ID. It's important to be aware of these different behaviors for secondary IDs in order to maximize your use of this feature. Dual joint mode is a DYNAMIXEL synchronization feature supported only by X540 size DYNAMIXEL actuators, making use of the integrated sync port featured on this size of DYNAMIXEL. To use this feature, you'll need to enter follower mode on the secondary servo through the drive mode control table item. Then, connect the leader and follower actuators with a DYNAMIXEL sync cable using the port I mentioned earlier. In this configuration, the follower will copy the leader's motion with the direction of the follower's rotation determined by the type of sync cable used. A standard sync cable will maintain the direction of rotation, while a twisted cable will reverse the operation. Registered instructions allow users to load instructions onto the DYNAMIXEL's control table for later execution. For example, a desired goal position can be loaded to multiple actuators to prepare for synchronized movement, and then executed at the same time by sending a single instruction packet to all linked servos. Synchronizing DYNAMIXELs in this way requires a different approach than other solutions. Instead of sending only the final synchronized command, the desired action has to be sent ahead of time, meaning this method lacks some of the flexibility used by other implementations. But it allows the queuing of any action, not just motions. While this can be used to achieve behavior similar to other synchronization options, registered instruction is best used for the single execution of complex movements, like startup or shutdown procedures that need to be executed simultaneously on power up or power down. The final method of DYNAMIXEL synchronization is the most complicated, as well as the most flexible. This method uses the sync and bulk read and write methods from the DYNAMIXEL SDK to interact with multiple DYNAMIXELs simultaneously. While sync and bulk functions may seem similar, there's one important difference between them. Sync packets must access the same control table items and send the same data for each DYNAMIXEL being addressed, while bulk packets can read or write to different regions and send different data to each connected DYNAMIXEL. In order to use these sync and bulk packets, you need to construct the packets manually in your control software according to the packet structure shown in our e-manual documentation. As you can see, there are several ways to achieve synchronized control of your DYNAMIXEL actuators. This flexibility allows you to choose the best synchronization method for your specific DYNAMIXEL project. If you'd like to learn more about any of the features mentioned in this video, or any other technical information about ROBOTIS products, please feel free to check out our online e-manual for more information. If you want to take a look at any of ROBOTIS' amazing open source projects, or contribute some code of your own, visit our official GitHub account. And if you want to showcase your DYNAMIXEL project, come stop by the Robotics community forum and say hello. This has been Jonathan with Robotics, and I look forward to building more with you soon.